So I'm going to continue with an introduction to the data structures, but I'm also going to talk a little bit more about the implications of these data structures, both in terms of how you might use the data in terms of your research questions, but also some statistical implications or psychometric implications and how you might handle some of these differences. This is going to be a more general discussion about teaching effectiveness and how we might develop measures and methods to evaluate teaching. It's less about the data, but it uses kind of the data as the background or the framework for understanding what some of these models might look like. So just a generic outline, just talk about the overview of the data structures. I'm going to continue from where we left off a minute ago. Talk about constructor-relevant variation. This is really where I'm going to focus the heart of my talk on and kind of introduce some of these ideas and ask for some people to raise some questions related to how their projects may be affected by constructor-relevant variation. And then we're going to talk about some of the implications. So we've talked throughout the session today about the structure of some of the data that you're going to look at, both in terms of the metadata, but also these structures are widespread throughout the education schooling. Generically, we might look at achievement data having a multi-level or hierarchical structure. We have, for example, students nested within classrooms or teachers, which are in turn nested within schools. This is the one we discussed earlier today and probably the one that you're most familiar with. There's also structures for most of the other types of measures that we have in our data set, and these include student survey responses, classroom observations, and all the other measures as well. And so what we're going to talk about is really trying to think through what are the structures and what are the implications of some of these structures. If you look at the tripod data, the tripod is a student survey measure, and so they're looking for students' opinions or perspectives on how classroom teaching is going. And so you could say, for example, that you have school, well, I should start all the way at the bottom here. So you have, in this particular diagram, we have I equals an item. So you have items nested within students. In other words, each student responds to a set of items on this tripod survey. We'll talk a little bit more about it in a minute. And then each student is in turn nested within actually a classroom or a section, which is in turn nested within a teacher, which is in turn nested within the school. So what we're going to talk about a little bit today is where your object of inference is, or your object of measurement is. Right? There's different objects of measurement. If you're interested in, for example, measuring the quality of teaching for a particular section or classroom, your target of inference is really going to be focused more on a particular section or the section level or the classroom level. If instead you're looking more towards the school level, in other words, what's the average level of teaching quality at a school across all teachers, well, your object of inference really moves up to the top level, and then you have to address the levels underneath in kind of fancy ways. So these structures are widespread and they're multi-layered in the sense that there's a structure of the data, in other words, the nesting structure of the students or of the tripod measures, such as these items nested within students, nested within sections, but there's also nesting within the actual instruments themselves. And if you look at observation systems, for example, a generic structure of many of the observation instruments or many of the teaching quality instruments really focuses on teaching quality being a broad or a general construct, and then they break it down into different domains. And then in turn, these domains are often broken down into different dimensions. And to a large part, to a large extent, the organization of the teaching quality, it's not clear whether these are intended to be a factor structure or whether these are intended to be more of an organizational structure of how you're actually coding and how we want to think about teaching. And so these are some really interesting questions that you can dive into with these data, is what is the factor structure of teaching quality, for example. And I know a number of people in this room are interested in those questions, as well as other researchers that have looked into this a bit. Let's take, for example, the class instrument, the classroom observation scoring system. It looks at teaching quality, breaks it up into roughly 3 different domains: emotional support, classroom organization, and instructional support. And then in turn, each one of those are measured by dimensions. And these are kind of the criteria that are measured within the classroom observation and scoring systems. And so to some extent, there's a multi-level or hierarchical structure even within the observation protocol. Right? Not only are we seeing a multi-level structure of the data, of the actual observation systems that we're using to collect the data, but there's also a hierarchical structure in kind of the theory or the organizational theory of how teaching quality may be organized. The structure of the observational data is somewhat complex. We start off with the teacher. each teacher is measured across multiple sections. Not all teachers are, but many of the teachers are in the data set. Within each one of those sections, there's multiple lessons, right? Usually about 2 lessons per year. And then each one of those lessons, depending on the observation protocol, are also measuring segments. In other words, there's multiple segments per lessons. I believe the framework for teaching only has, I think it's a daily measure, so it's only 1 measure per lesson or per video. So there's actually not segment level scores, but for the other ones, there's tend to be. And how segments are defined, again, is dependent on which observation system you're using. And then even within the segments, we're looking at multiple dimensions or multiple indicators. In other words, if you're looking, for example, if you're looking at the mathematical quality of instruction, there's multiple indicators within each segment, talking about the richness of instruction or the errors or imprecision of the teacher. And so we have a fairly complex hierarchical structure, but this structure actually turns out to be cross-classified in a lot of ways as well. And one of the ways is that if you look at the raters, what we see is that raters generally rated entire intact lessons, and they rated multiple lessons from different teachers. And so now you have this kind of cross-classified structure. You have lessons being nested within a section, but also concurrently being nested within another hierarchical unit, an independent hierarchical unit, which are raters. And so lessons are actually cross-classified by sections. Lessons are actually cross-classified by sections as well as raters. And so this adds a lot of complexity into the data set and how we might think about addressing some of these sources of constructed relevant variation, which we'll talk more about in a minute. It's useful for me to kind of map these out ahead of time because it helps to kind of structure my thinking in ways that can address the kind of important features of some of these observation systems. Without just doing something like this, it's tough for me to grasp what it actually might look at and what things I need to attend to. So moving forward, we're going to talk a lot about the object of measurement. In other words, what it is you want to measure in your particular research project, right? The object of measurement is really focused on the target of our inference. It could be different for different studies. There's not a single target of inference or object of measurement. It depends on what you want to study in your research project. For example, if you're looking at the student surveys for the tripod instrument, you may be interested in constructs at the student level, or you may be interested in constructs at the classroom level, or somewhere higher up the hierarchy, maybe constructs at the school level. And so the object of inference or object of measurement is really dependent on your research question. If you're focused on student level constructs, then you're really looking more at the object of measurement is really the student level construct. If you're looking at the classroom level construct, and it's more at the classroom level. And then all the other sources are kind of contributing noise or error. So I keep bringing up this term constructed relevant variation, and to some extent many of you may be familiar with it, but I just want to go over some of the ideas and provide some conceptual motivation as to what constructed relevant variation is and how it ruins your day. Or at least mine. I have nightmares. I wake up many nights thinking about what sources of constructed relevant variation I've missed and how in the world I can actually track them in really good ways. So I'll abbreviate constructed relevant variation using CIV because it's a pretty long term. So construct irrelevant variation is variation stemming from sources other than the object of measurement. Or generically you can think of it as the noise, the stuff that gets in the way of measuring what you really want to measure. And so the sources and extents of constructed relevant variation are heavily dependent on the instrument and the data collection system, but also the nature of the construct being measured. So let's take a couple examples. Let's look at the tripod. So are most people familiar with the tripod measure here? It's a measure of student perception of the teaching quality or the teaching effectiveness going on in the class. So each individual student in a classroom responds to the survey. And then usually or generically the goal is to draw, even though the survey is given at the student level, the goal is usually to draw inferences at the class or the teacher level. So primary sources of variation in observations, I'm sorry, I skipped over. This is actually observation system. So we'll come back to the tripod in a minute. So if we're talking about observations, again, we had that structure a minute ago. We had kind of items or indicators or dimensions nested within segments, nested within lessons, and then lessons were cross-classified by raters and sections, and then in turn sections were nested within teachers. right, depending on your level of inference. So again, depends on your research questions, but let's pretend for a moment that you wanted to focus on teaching persistent quality. In other words, the persistent quality of teaching across all observations and across all sections. Now that may or may not be the interest that you have, but let's pretend it is for the moment. So the primary sources of variation in observations are going to be, of course, the teachers, in other words, the persistent teaching quality, that's the object of measurement or our target of inference. We have sections, in other words, quality can vary from one section to the next for a number of reasons. It may be that there's some relationship between, well, a teacher may be better at teaching a certain group of kids than another group of kids. And then lessons are also a source of variation. In other words, quality varies from one lesson to the next. Temporal deviations, for example, or bad days. And then even within a lesson, quality may vary from one section to another. And then we have raters introducing variability as well. In other words, raters may be more lenient or more severe than other raters, or at least relative to other raters. And then we have variation that is often not considered, but there's actually variation at the item level or the dimension or indicator level. And this stems from differences among items. In other words, a particular item may be more or less related to the underlying construct of interest. And so that can actually introduce construct-irrelevant variation as well. And then, of course, we have interactions. And variation can arise from a number of different types of interactions, but, for example, a rater by teacher interaction. In other words, some raters may be more severe with certain types of teachers than other teachers, right? And so we want to introduce those. Sometimes that's called rater differential functioning. And there's interactions among many of these different components, so this becomes pretty complex pretty quick, right? And trying to track these different sources of variation are really challenging. So in terms of our question that we had a minute ago, if we wanted to measure teaching persistent quality, a teacher's persistent quality across all sections, all lessons, all observations, all segments, the primary source of variation that we're interested in would be teachers, the variation stemming from teachers. In other words, those stable or consistent differences among teachers. Everything else is construct-irrelevant variation. That's all the noise that we actually have to take on or to address in order to get to the thing that we want to measure. And so in a lot of situations, construct-irrelevant variation is fairly small or fairly negligible, and you can kind of push it aside because the signal, in other words, the thing that you're trying to measure, the object of measurement, overwhelms the noise. But what we'll see in a minute, we'll do some empirical investigation of these, or empirical estimation, and we'll see that in many situations, the noise overwhelms the signal. There's actually more noise than there is signal in a lot of these measures. So I've given you a little bit of an introduction or conceptual introduction to construct-irrelevant variation. I just want to talk about it a little bit more in terms of how you might apply it practically or what it might mean in terms of framing it. And so there's an interesting passage in the Gitomer and Bell book, and I'm just going to read it. And this gives a kind of conceptual motivation to what construct-irrelevant variation actually is, and we're going to draw from another field and realize how that might apply to our field. So imagine two surgeons. We'd like to evaluate them on the quality of their surgical skills using multiple measures. In other words, how good of a surgeon are these surgeons? Right? How well do they do surgery? We'll use the size of the scar, the rate of the infection, and the quality of the pain management and patient satisfaction as our measure of quality for their surgical skills. These are the outcomes of interest. You know, analogous to this might be in education. We might be interested in their value-added scores or their student achievement or their observation scores. Let's pretend that one is in Miami, Florida, and the other one is Moshi, Tanzania. Both must remove a benign tumor from a 53-year-old man's abdomen, and the surgeon in Miami has a number 10 blade steel scalpel that is designed for cutting muscle and skin. The surgeon in Moshi has a well-sharpened utility knife that is used for a range of surgical purposes. The excision in Miami will occur in a sterile operating room with no external windows, fans and filters to clean the air, and an anesthesiologist and a surgical nurse. The excision in Moshi will occur in a clean operating room washed with well water and bleach, windows open a crack to allow a breeze to circulate the stifling hot air, no fans or filters, and a nurse borrowed from the pediatrics unit because she was the only one available. At the end of the day, we're going to judge these two surgeons based on the outcomes of their patients. But clearly, there's other stuff going on here, right? There's an entire system that's actually influencing, that is likely to influence these outcomes. And that's construct-relevant variation. In other words, what type of scalpel you use or what type of knife you use to conduct the operation may have an impact on the quality outcomes that you're looking for. And so without taking those into account, without adjusting for those or somehow taking those into account, what we're going to see is probably that the health outcomes of the person in Miami are going to be much better than the person in Moshi on average, right? And so finding ways to kind of level the scale, in other words, to kind of adjust for the construct-relevant variation in ways that put the surgeons on the same scale is going to be one of our primary objectives. It's also a very challenging objective. Moving on. One of the tools that people often use to kind of understand construct-relevant variation and map its magnitude is generalizability theory. And generalizability theory tries to decompose a measurement error or the observed variability into distinct sources. One being the object of measurement, in other words, your target of inference, what you actually want.